All right, guys, so we are going to add on to the ionic naming that we did yesterday, and we're going to look at what happens when our metal is a transition metal. So what makes transition metals different is many transition metals can form more than one cation with different ionic charges. So whenever we are naming or writing the formula, we need to know which charge of that cation we have. So the charges of cations must be found from the number of electrons lost. So, for example, iron has two possible cations. There's the iron +2 charge whenever it loses 2 electrons. And then there's the iron +3 charge whenever it loses 3 electrons. And these can lose electrons from the S block and the D block, which is why they can have different charges overall. The naming system that we use for these is the stock system. In the stock system, we use a Roman numeral in parentheses right after the element name, right after the name of the metal. And this is used to designate the charge of the ion. So the Fe+2 is referred to as the iron 2 ion with that 2 in parentheses. And the Fe+3 is referred to as the iron 3 ion with the 3 in parentheses afterwards. So, for example, if we have these ions, CO with a +3 charge, CO is cobalt. So this is going to be the cobalt 3 ion. Chromium can also be 3, but that's going to look the same. Let's go down to the Ni+2. Ni is nickel. And it's going to be 2, so the II in parentheses. And then Pb4 plus. A lot of those metals underneath the stair step on the periodic table can behave as transition metals. So lead is, or Pb is lead, which is one of those. And this is the lead 4 ion. So make sure that you're familiar with Roman numerals 1 through 5. You shouldn't go above 4. But remember, it's I for 1, I for 2, I for 3, and then IV for 4. If you have a 5, it would just be a V. That's not as likely. You don't have to draw like the lines above and below, but make sure that you have the parentheses showing that charge. All right, and if you're following with the notes online, I skipped a couple of slides that are for honors only that I will do in a separate video for our honors class. But like we said, most transition metals can have more than one charge. There are a few transition metals that can only have one charge. So these do not have the stock system. They do not have Roman numerals. So these you have to know their charges. So you must remember the following. The 3 that you have to know that only have one possible charge are silver, which is Ag with a +1 charge, cadmium, which is Cd with a +2 charge, and zinc, Zn, which is a +2 charge. How I remember these, I'm going to try to sketch it out for you a little bit. If you look, that group 3A, which is a +3 charge that has like boron and then aluminum. Sorry, my drawing's a little off. So aluminum is a +3 charge. If you look in the column before aluminum is where zinc and cadmium are. So that's why they're a +2. The column before that is where silver is, which is where it's a +1. So you can figure out the charges based off of where they are. That may help you. But those, when you name them, will not have Roman numerals. And whenever you're writing a formula and you need the charge, you have to remember those specific charges. All right, so actually let's kind of put this to practice. So if we have a compound that has a transition metal that can have more than one charge, so not the silver, zinc, or cadmium, we have to figure out which charge we have and write it using the stock system, or if you're in honors, add the classical system, which will be in a separate video. For example, if we have CuO, how we know the charge, or excuse me, CuO. Cu is copper, which is a transition metal. And then O is oxygen, which is oxide. We find the charge of the copper based off of the charge of the oxide. So since oxygen has a -2 charge and it has to have a balanced formula, copper has to have a charge of +2. So to show you this, if oxygen is -2 and these have to add up to equal 0, because remember compounds are neutral, copper has to be +2 for them to cancel out. So this would be copper 2 oxide is going to be the name of this. You can also uncrisscross these, but you have to make sure that the formula has not been reduced. So that tends to be a little bit trickier. So let's name the following compounds containing transition metals. And we're just going to do the stock system. The classical will be in a separate video for honors. So our first one, we have SnF2. Sn, if you look it up on the periodic table, is tin. That is number 50 on the periodic table, so you can locate it. It is underneath the stair step, so it still behaves like a transition metal, so we do need Roman numerals. We just have to figure out what that Roman numeral is. And F is fluorine, which is going to become fluoride. So to find the charge of tin, we have to first look at what is the charge of fluoride. So fluoride is going to have a -1 charge, but note that there are 2 fluorides. There are 2 -1s. So this is a total of -2, meaning that tin, in order for them to cancel out, has to be a +2. So this is tin 2 fluoride. Just to show you how this is different, let's look at the next one. Here we have SnS2. So Sn we said was tin. It is underneath the stair step, so we do need Roman numerals. S is sulfur, so in a compound it is sulfide. So to find the charge, sulfide is underneath oxygen. It's in that group 6A, so it has a -2 charge, but there are 2 of them. That means that this is a total of -4. So tin, in order to cancel out that total of -4 charge, has to be a +4. Let's look at the next one. We have CrN. Cr is chromium. It does need Roman numerals. N is nitrogen, but in a compound it's nitride. So nitride has a -3 charge, and there's only one of them. So chromium has to have a charge to cancel out the -3. So chromium would need to be +3. Going the other direction, it behaves just like any other ionic compound where you write the symbols and crisscross your charges. So if we look at iron 3 oxide, iron is Fe. The 3 tells you that this is a +3 charge. Oxide is oxygen, which is O, with a -2 charge. So as we crisscross these, iron gets the subscript of 2 from the oxygen, and oxygen gets the subscript of 3 from the iron. Let's look at this last one. We have copper 2 sulfide. Copper is Cu. The 2 tells us it's a +2 charge. And then sulfide is S with a -2 charge. Sorry, I had some technical difficulties. There we go. Oh, and sorry, it cleared my screen whenever I had some difficulties. Go through your homework and practice with this. So remember, the only ones that will not have Roman numerals are the silver, zinc, and cadmium. Those are going to look like any other ionic compound.